Alright, here we go with the last video. We're going to do these two problems right here, which are going to be a little bit harder than the last one, but still not so bad. So we're going to start with this one. One arch of y equals sine of x is rotated 360 degrees about the x-axis. Find the volume. Now, the ones I've been doing are all 360 degrees, but you could very easily do some other degrees just by using some type of ratio, right? If you use 180 degrees, then it'd just be 180 over 360, which is half of that. So you can use ratios to find if it's not quite 360 degrees or not quite 2 pi if we're in radians. But let's go with this one, y equals sine of x. Okay, now we're just looking at one arch. So we know that looks something like this. And it goes up to 1. It goes from 0 to pi. And so that's our one arch that we're then going to be rotating around, which is going to give us this kind of cool shape here. And so it'll have some type of, like flattened ball or something there. But anyway, we're going to be finding the volume of that. And so what we're going to do is we're going to go, now the pi, I've been writing it inside. If you want, you can just write it outside. It's a constant. It gets pulled out. So we're going to go from 0 to pi of sine of x squared dx, right? So pi f of x squared dx. Now, we learned before that to take the integral from 0 to pi of sine squared, we're going to have to do something a little bit different because we can't just use use substitution. We can't just take the integral because there's a square, so it's a little bit messy. But you may remember there's the double angle formula that says cosine of 2x is equal to 1 minus 2 sine squared of x. And if you rearrange that, then you end up getting that sine squared of x is equal to 1/2 x minus 1/2 minus 1/2 cosine of 2x. And so then we can just substitute this in, which means we're going to have pi integral from 0 to pi of 1/2 minus 1/2 cosine of 2x dx. And then we can take the integral because we can do the integral of 1/2, which will be 1/2 x. We can do the integral of 1/2 times cosine of 2x because we know the integral of cosine is sine. But because of the linear piece that's inside of there, you then have to multiply by the reciprocal, which is 1/2. And so we're going to end up having 1/4 sine of 2x. And all this will be integrated from 0 to pi and then multiplied by pi because the pi is still just hanging out there waiting. So we go pi, and then we'll go 1/2 pi, which that'll be pi over 2, minus, and then if I put pi in there, I'm going to have sine of 2 pi, which is a 0. And then all of that is going to be minus, and if I put 0 in there, then I'll get 0 minus, and then sine of 0 again is 0. So that's quite nice. All of that goes away, and so we end up getting pi times pi over 2, which gives us pi squared over 2. Now, if we do that on our calculator, just because I want to check it on this thing, so we'll go pi squared divided by 2, and I get 4.93. Okay, approximately. Sorry, I should approximate 4.93. So let's go check it out here. We're going to change our equation to y equals the sine of x, and we'll go from 0 to pi. So let's go ahead and we'll get rid of our area here. Okay. So we're going from 0 to pi. We'll stick with the rectangles for now. Alright, we can zoom in a little bit so we can see that a little bit better. Okay, and we'll go ahead and go back to the divisions. So you can see as we increase the divisions, we get better and better volumes there. And so eventually we should be able to get what we hope is the correct volume of our little shape there. And if we go, let's go all the way up to 200 divisions, you'll see that our area is up to almost 2. Yeah. And the volume is 1.571 pi. And if we do 1.571 pi, 1.571 times pi, then we get what we hope, 4.94, which is what we said it was, 4.93. So we're approximately at the right place. So anyway, we've managed to find the volume of that being rotated around the x-axis. Let's do one more. This time we're going to deal with 2 lines. So we've got the volume generated by revolving the region between y equals x squared and y equals square root of x about the x-axis. So you've got y equals x squared, which we know looks like this. And you've got the y equals square root of x, which you know looks like this. And so there's our region right there. That stuff right there. So let's think about this and see if we can get it to work with what we were talking about before. Again, we've got rectangles, right? And so we're going to deal with those rectangles, and we're going to take those and we're going to rotate them around the x-axis there. Okay? Now, the way this is going to work is, there's a couple of ways to prove this, but the easiest way, I think, is by saying, okay, well, if I were to take the red line and revolve it around, then I'm going to get the volume of everything inside the red line. Okay? The volume of the gray section is that subtracted by what I would have gotten if I would have done the integral and revolved the blue line around. Okay? So essentially what it is just the same thing. It's the integral of pi times the red line squared dx minus the integral of pi times the blue line squared dx. Right? So I take that volume and subtract the volume inside, and that leaves me with the volume of the area that I want. Okay, another way to write this, of course, would be pi, because these integrals are the same from whatever this number is to whatever that number is, 0 to 1, of course, of red minus blue. Or in terms of what we've seen before, pi times the integral of y squared, y upper squared, minus y lower squared. Okay, and by doing that, you could then find the volume of that section. Now, if you want, you're more than welcome to go ahead and do that by hand. If you want, I'm going to show you how to do it on the calculator, just so that we've got it on the calculator. So let it not be said, I never showed you how to use a calculator. So in this situation, we do need to find where they intersect. So one way you can do it is just go straight in here, and we'll say, okay, let's pretend that I didn't know that they intersect at 1, 1. Okay, so I'll go y1, which was x squared, and I'll do y2, which is the square root of x, and then I'll graph it, and I'm probably going to need to go to a different window. I have no idea what this window was in last, so let's just go zoom 4. Alright, so there we go, there's my x squared, there's the square root of x, and then I'll go second calc, and I'll find the intersection. Okay, and we'll go a little bit closer to, I guess that's the first curve, second curve, and then my guess I'm going to put right there. Of course, it'll give me my intersection of 1, 1. And then I do know that they cross here at 0, 0. All right, and so now I should be able to do the integral. And so when I do the integral, I'm just going to go to the home screen here. All right, and I'm going to go shortcut fn int, which is 4. And I'm going to integrate from 0 to 1. And then I'm going to do the upper minus the lower. So the upper is the square root of x. So that was y2, right? I made this y1, and I made this y2. So on my calculator, I'm going to go F4, and I'm going to do y2 squared minus y1 squared, and then I'll put in my dx, and I push the enter, and it gives me 0.3. And like I say, you can, that is 0.3, and then I forgot the pi, so 0.3 pi, which then is your final answer. Now, you could have done this by hand in fact, I encourage you to go ahead and try it by hand, see if you can do it, and then hopefully this will help you out. Keep in mind that if these two lines were to cross again, that the one on the outside, the one on the inside might change. Some of you said, well, can't I just break it up and then work it out, and if it's negative, just make it positive? Yeah, you can do that. But again, you still need to find where the intersections are, because you need to know where to break it up so that you're not accidentally combining the positives and negatives. Okay, so the principles that apply to area are very similar to the principles that apply here. So hopefully that's helpful. Hopefully you'll be able to use that as you start on your homework tonight. Ciao.